So in this video, I'm going to go through how to solve for the partial derivatives of four different functions. So we're going to start off with this first one, where we're asked to find the partial derivative with respect to both x and y of this function of x and y. So I've popped it over here, and let's start off by figuring out the one with respect to x. So remember, the general rule for applying partial derivatives is that everything other than the variable you're taking the derivative with respect to is going to be considered a constant. So if we look here, we want to take the derivative of 4x with respect to x. So this one's pretty straightforward. It's just like a normal derivative. So the derivative of 4x we know is just a constant that sits out the front of 4. Now, however, what we've got is the derivative of 2y, and because we're taking the derivative with respect to x, we're treating y as being a constant. So essentially overall here we've got a constant. So the derivative of a constant we always know goes to 0. So it's going to be 4 plus 0, which is just 4 overall. So therefore the derivative of our function f with respect to x is just the number 4. So now let's do the second part, which was taking the derivative with respect to y. So this time we're going to consider x, our other variable, to be constant. So if we take the derivative of a constant 4x, okay, with respect to y, the derivative of that would be 0. If we then look at our second term here, we want the derivative with respect to y, so we are considering y to vary here, and the derivative of 2y with respect to y would just be the 2 that sits out the front. So overall, we find that the derivative with respect to y is just going to be the 2. Alright, so let's move on to the next one, part B. Again, we're asked to find the two partial derivatives for our function of x and y. And this one's going to be a little bit trickier because x's and y's are multiplied together within the same term. So I'll start it off again by looking for the derivative with respect to x. So looking here at our first term, all right, remembering that everything other than x is being considered a constant. So that means that y is constant. So if we want to take the derivative of x squared y, all right, our constant is going to sit out the front, and then we're going to just apply the derivative of x squared. So we know that using our power rule, it's going to be 2 times the 1 that sits out the front, which is 2. X, take 1 off the power, 2 minus 1 is 1, so there's an implied 1 up here. Alright, so let's move on to our next term. So again, we're considering y to be a constant, which means sine of y is a constant. So overall, the constant part of our term here is the 7 sine y, and then we need to take the derivative of the x, right? And the derivative of, just like up here, when we took the derivative with respect to x, it's just going to be the constant that sits out the front, which in our case is the 7 sine y. So we could rewrite this a little bit neater. We're going to get 2xy plus 7 sine y as being our partial derivative with respect to x. So now we'll do the other one. So f with respect to y. So this time, since we're taking the derivative with respect to y, the x is being considered constant. So if we look here, all right, x squared, that's just like considered like a number out the front, just like up here when we had the 2. So when we take the derivative with respect to y, the derivative will just be that constant, x squared. So if we now have a look here, again, we're considering the x to be a constant. So overall, the constant is 7x. And then we need to take the derivative with respect to y of this sine part. So the derivative of sine goes to cos, so we're going to multiply by cos, and it's going to be of y. So if we write this a little bit neater, we get x squared plus 7x cos of y. So that would be our answer for the second partial derivative. Alright, so for the next one, part C, we're looking for 3 partial derivatives, okay, for the 3 different variables that we have in the equation. So if we scroll down, again, I'll start with taking the derivative with respect to x. So if we're taking the derivative with respect to x, our other things in the equation, so y and t, have to be considered constant. So looking at this term here, all right, the constant that sits out the front can essentially be considered the 3y, and then we need to take the derivative of x squared, since we're looking at derivative with respect to x. So applying our power rule, it would be 2x to the power of 1, which I'll just leave off that 1. So if we look at this second term here, all right, t and y are considered constants. So overall, this is just going to be a constant. So if we want to take the derivative of a constant, all right, it's going to be 0. So overall, we end up with an answer of 6xy for the partial derivative with respect to x. All right, so let's do the next one, which is the partial derivative with respect to y. So now, since we're considering y, all the x's and all the t's are being constants. So looking here, if we want to take the derivative of 3x squared y, the constant that sits out the front is the 3x squared, and when we take the derivative, the y disappears. And if we look here, all right, our constant that sits out the front is going to be the 9t, and the derivative of e to the y with respect to y would just be e to the y. So this here would be our, derivative with respect to y. All right, so we have one left. We also want to get the derivative with respect to t. So I'll pop that out on the end here. So this time that means x and y are considered constants. So looking at this first term, x and y, all right, constants, so therefore this whole thing is a constant. The derivative of a constant is 0. So that one's easy. So now we look at this second term, all right, y we're considering a constant. So overall we could write this as 9e to the y out the front. And then we just need to take the derivative with respect to t, which is just going to be leaving us with the 9ey. So overall our answer here is that. All right, so we have one left, part D, and again we were asked here to find the derivative with respect to the 3 independent variables inside the equation. So let's start off with the derivative with respect to x. And this time actually what I'm going to do is I'm going to put the y on the top line. And remember that you can have an implied 1 here. All right, so when you flip it to the numerator, you change the sign on the index. So it will go to -1, and then we've got still that sign of t on the top line. And this is just going to make it easier for us to take the derivative of the function because it's written in terms of a nice power. All right, so taking the derivative with respect to x, that means that y and t are being considered constants. So overall, the constant that we could write out the front would be the 9, the y inverse, and the sine t. And then we need to multiply by the derivative of the x cubed with respect to the x. So applying our power rule, that would be 3x squared. So I could write this a little bit neater. All right, we've got 9 times 3 is 27. I'll pop the x squared and then the sine t at the top. And if we wanted to, we could flip the y down to the bottom line, or you could equally write it on the top with the y inverse, or -1 I should say. Alrighty, so that's our answer for the first partial derivative with respect to x. So let's move on to the next one where we're looking at the partial derivative with respect to y. So this means that x and t are being considered constants this time. So I'm going to write out my constant out the front of this expression is like the 9x cubed sine of t. And then I need the derivative of y to the power of -1 with respect to y. So applying my power rule, -1 multiplied by the 1 that sits out the front. Write out my variable and take 1 off the power. So that takes it to -2. So now I just need to write this out neater. So I've got -9 over all. I'll put the x cubed and the sine t on the top line. And I'm going to choose to shift this down to the bottom. So flips over the sign and it becomes y squared. So that there would be my answer for the partial derivative with respect to y. So we've got one left, which is the derivative with respect to t. So this time, since we're looking at t, it means x and y are constants. So the overall constant that sits out the front here is going to be the 9x cubed y to the power of -1. And then we need the derivative of sine t with respect to t. So the derivative of sine is cos, so we end up with that. So again, if we want, we can flip the y down to the bottom to make it look a bit neater. But equally, you could leave it on the top. It's the same thing. So that would be my answer for the derivative with respect to t. So that's all there is in terms of this video.